Okay, I just wanted to speak a bit about the steps you should follow when you first looking at your magnetic data. I've got tips on like what menus to use instead of that. But before that starts, just a broader picture of the different things you should be looking at. And really I've only done this once or twice. I'm not experts on the walls. I'm just sharing the little that I have met. And please comment below if you got more than you wanna add to it. I'm sure people have some great idea. And so this was a study that I was doing in the southern region of South Africa. So here's South Africa. And you can see this big magnetic strap here. That's called the BT magnetic anomaly. And so I was trying to look at it. And so the layout of this paper. I really followed a federal student who was doing a PhD at the head of me. And she had just a great layout in her papers. I followed it quite closely without bordering a plagiarism. And just her workflow. And really helped a lot with me to understand. And so I started out with just looking at a broader regional picture. And so often we zoom into our area. And we don't just try and understand the larger tectonics that are affecting the area. And just the tectonic settings of our region. So I plotted the here on the left is magnetic data. On the right is the free air data. And below here is over here is our aesthetic anomaly gravity. And normally, I'm not gonna talk too much about that. And then I'm on to the boundaries of the different tectonic provinces. You can see here we've got a creton. Here's an overbelt. And then we've got a younger fold belt in the south. And I was lucky that I had these reasons still in here to by my supervisor. She gave me the shape bombs. But it's really not hard to create shape thoughts for you. Area, and there's no excuse not to have these on your maps. I'm pretty sure I've got some movies on how to you each create shape files in Geosoft. If not, I can go back and create some, and I'll trap. If I've got them already, I'll put the link in the details below this video. And so you can see here this strong magnetic anomaly lies mostly in the Mac Unitel mobile box. It's a younger proto-reserve box. And it just helps you to see some of the features across the dataset. Mainly what you obviously seeing and free is the topography. You see here is the edge of the escarpment of South Africa. And the reason why I had the free air was because I was moving on to the other static anomaly, but most of the time people just look at the magnetic data on the left here, or the TMI total magnetic intensity. And in the brigade normally here. And you can see how well this edge of the creton correlates with this blow on the creton. Okay, so just a map that gives you the settings. And then I move down, let's just shift down a bit. And there's some magnetic susceptibility data. So thankfully, in South Africa, we have an atlas of susceptibility values from across the country. And I just use those to create some tables of the different rock types. And what this is instability means B. And dearly you've got some from your sample area. If not, unfortunately, we'll have to use receptibilities from textbook variants. And some. I went to a workshop recently that actually said plotting rock top against susceptibility is not the best way that you can see. There's such more brain just than this actually. You should have a TNUI diagram. That was it takes into account the composition of the rock. Not all rocks, not all granites are the same. -1, but I can't explain more that year. So maybe hopefully, in the future we can upgrade our physical property plots. And then I moved on here. Zoomed in a bit to my area, but I'm actually And so on top here, I've got the magnetic. Sorry, the total magnetic intensity. So the magnetic map. And then underneath here, I did a high-pass filter. -1, and so the whole point of it is that in my area this beat, the anomaly that I was looking at is so strong that it kind of swamps out all surrounding anomalies. Except on the coast gem. You see a bit of a strong anomaly on the right-hand side here, which is called the Williston. Lowers them by she. And you really don't see if they continue it at all. But as soon as I did this high-pass filter, it took away just the dominating feature. That was the beauty, and every line really sure that there was continuity on the walls. Williston and Laverley and end on the bushy. So filtering really just helps maybe sometimes take out your big signals that may be original. And hope you see some other. The smallest signals in they. And I was able to draw these linear ones. It also allowed me to see But you can't see it on the magnetics as well. That this magnetics over here, it's quite different from this on the right-hand side here. And so that there's actually a divide here between the two terrains. Wasn't the first person who said this. It's actually based on borehole data. But the filters also helped you to easily see on the right-hand side with these long anomalies. On the leg and the waist here, you got these shorter wavelength, long piece or smaller features. So that's where the filtering helps. But that's not the best figure to see this. If we go down here. So now I'm focusing on the east coast of South Africa. This is a plot that I really like. And that, like I said, I got from the -1 at the student. Just the stress order. This is zooming in on the coast. Here's the speech anomaly I was talking about. Here's the Williston anomaly. And this is the normal magnetic data. And these black lines are shear zone. And you can see that this match shear zone. Black lines on surface correlate very well with these high magnetic anomalies. And then on the right-hand side, what I did here was a low-pass filter. So previously I had the high-pass filter. Showed me the continuity here. The low-pass filter is showing me what features they are, says blocking out the shadow. showing you what are your deep anomalies. And you can see this share zone here, which is the boundary between the Cranton and the Proteus. Roosevelt it's strong. So it's very deep. And here's your beat. He's also deep, but you still getting these other shoes at. And showing that there are deep features. And I'll just show the future. The other thing that I did down here is the tilt derivative, and you can see how much detail it brings up. All these shares of it. Not gonna talk too much here about the pseudo-gravity. Mainly because I've forgotten. But they're just different filters. I mean, you can also do your vertical derivative. And to understand your shell of features. And your tilt to return. To understand your shell of features. And in your local possible to understand what is deep in your area. And really at this point in time, you're just trying to understand what signals are there. So you can understand better what the heck you gonna be modeling when you go into 3D. Another thing that I've never done, but a colleague of me minded, so I wanted to share it here, is she created this map of Houston area. Unfortunately, I don't have the original mag, but you can see she picked up new features. And this was in GSAF. And so I asked her for how she did it. And so you can see here, this is that GSAF's how to God. ET group analysis. Creating structural complexity maps. And they've got a great image here. That you can see. Here's the mag. And then here are these linear ones that they have. Delineated and put on top. And then you can create a map of those lineaments. Which is pretty much what my colleague did. So that's also just a great way of showing people linear in your area. I think it also might help. You could plot these types of limit. Or maybe the gravity data and see how they compare with it. So that's another thing you can do. Playing around with your data. Then you obviously wanna look towards dead estimates. And in just off. It's very tempting to use the old 3D. Because it is there. But I think something I've learned from my master's and my PhD is don't jump to 3D too quickly, start on 2D. 2D makes a world of difference, just helping you understand. But before you get too much data, that it's just hard to understand, and so I do have a video of some free 1D Euler software. Answer really. I can honestly say I used the Euler 3D in Geosoft during my PhD, but never actually published the data. Because it made no sense to me, and maybe else it just ran out of time. And so don't use it too quickly. Start here with this Euler UM1D or. And that's really profile data. And it just helped you understand what is going on in this area. So this is the video here. Euler's software. Potential field. Did estimates along a profile. It was developed by Professor My university. Professor Gordon Cooper. And the links here, and the YouTube video. Take you to where you can download the software. And just to give you an example of what some of the things look like. So this is your magnetic data here, and this black line. That's obviously over a dark. 'Cause this is a dark signal in South Africa. And it calculates the RTP data. Here are some of the gradients. And you can see here I've got all deck the estimates with. I would assume that the black is 0.5 structural index and 1 is the reds is. One structural, you can see it's a bit complicated. I say it's an easy model. So I would know that the top of the dark is here. I'm sorry. The dark is the structural index of 1. 2 would be red. I think I might be wrong. But this is easy data. So all it gets very confusing very quickly. If it's complicated data, and you know 100%. And surely a structure index, isn't it quite fun? Of all contact is 1 for a dime. And what is your wonder size? That's our. Depends on the gridding of your data. Or the station space in your data. There's just a lot of different inputs that you got to deal with that. That's why I would say, understand a profile first. Understand what's going on in the profile of your data first before you jump to 3D. Unfortunately, I don't have any 3D videos because I didn't think to make it at the time. And I no longer have access to that menu. But yeah. Start with this first. Try this out. Let this make sense to you. So that you can understand what parameters you can then plug into the 3D data. And then you're gonna look at things like modeling. Now modeling is also very difficult. So let's zoom down here. So these were some models that I created using GM6 meters Geosoft. And so you can see on top here. This is a plan view of my magnetic. So I can see where my profile is going. This BMA over here is the BT magnetic anomaly. Over here I've got the magnetic data. Below I've got the gravity data. So you can see I'm not really seeing anything here. And then I created these models based on several datasets. Now that's the problem with magnetic modeling. Is that no reason to believe you're admitting one thing. And this year other day you say it's too bad for life. Poor whole sons make. I think I've got an MT here. So you can see scrolling down this is silent reflection data I had. This is seismic refraction data. This is an MT data. And you can see it's mostly based on the size we care. And the different colors here represent a top here different susceptibilities. And the second model different densities. And so not much change in the densities here. That's why you're not seeing much. -1 and especially on the coast of South Africa. Most of the gravity signal here is due to changes in the motherhood. And so even then that it's another safe day to set up water in here with crystal thickness estimates. Because if you are trying to model crystal thickness, and you're modeling gravity, and you're mothering shadows, that nobody's gonna leave yet. Yes, it's come straight for other day to sense. And so don't jump too quickly to modeling. If you don't have other day to sense to help you. But yeah, the Geosoft is great. 'Cause it can allow you to see all of this. And it can allow you to display other images in the background. And I hope you can strain your day to yourself. Showtime estimates. And so yeah. I suppose it's one of the last things you'd be doing this modeling predator. So those are just some of the steps that you can take when you're interpreting your data. You can see I did a second profile. Create other magnetic data. And then this is just some data in an Antarctica. Because South Africa was connected to Antarctic during Gondwana times. So just showing how the nominees can. So just putting your study into a broad and global context. But yeah, so those are some possible steps to find out while doing magnetic. Mind thing, good luck.